Hi there, everybody. Today we are going to discuss section 12.1, stoichiometry. Stoichiometry is a fancy, fun word to say, but what does it mean? The definition for stoichiometry, according to what we're using it for, is using balanced chemical equations to convert a known amount of one substance into an amount of another substance. The key point here, and the most important part of that definition, is balanced equations. The equation has to be balanced in order for it to be useful. Think about an equation as kind of like a recipe in foods class or in the kitchen. If you had a recipe that had absolutely no numbers with it and told you no amounts of how much ingredients to use, that wouldn't be very helpful at all. You have to know that you need 1 cup of sugar and 2 eggs and a teaspoon of vanilla in order to successfully create your recipe and what you're trying to make. The reason why these are particularly helpful in chemistry is that the coefficients in a balanced equation tell you the mole-to-mole ratios of substances that are involved in this reaction. So let's take a second to look at this particular reaction here. You have 2 H2 gas plus 1 O2 gas yields 2 H2O liquid. Since there's no number written in front of the oxygen, we assume that that's an implied number 1. I think you're all pretty familiar with that, and we usually just don't take the time to write a 1 there, but you could write a 1 there. And so if we are taking this statement that the coefficients in a balanced equation tell you the mole-to-mole ratios of a substance, then we could write some mole ratios for this balanced equation. For example, I could say that 2 moles of H2, since there's a coefficient of 2 in the balanced equation, is equal to 1 mole of O2. It would be a 1 mole to 2 mole ratio based upon the coefficients. I could also write the relationship that 1 mole of O2 is the equivalent of 2 moles of H2O because there's a coefficient of 2 in front of the water. We could write a third mole-to-mole ratio saying that 2 moles of H2 is going to be the equivalent of 2 moles of water. All right, so why is this going to be helpful in chemistry? Well, now we can start taking those ratios and using them to convert from one substance to another substance. So I do want to tell you, if you don't have a calculator in front of you right now, I would pause the video and go get one because we're going to start doing some math from here on out. All right, so our first sample question today says, how many moles of water can be produced from 2.5 moles of H2? We are going to begin by writing the number and unit that we are given in the problem. So in this case, we have 2.5 moles of H2. Let me pick a different color that'll kind of stand out here. So I'm going to write the number and unit that I am given, 2.5 moles of H2. And I am supposed to convert that to moles of water. Now, as long as I have a balanced equation relating those two substances, H2 and water, I can go from moles of one thing to moles of another in one step. And we are going to continue to use the convention that you put the unit that you would like to lose in the bottom of the factor and the unit that you want to go to in the top of the factor. Mathematically, remember, you're going to multiply by the top number and divide by the bottom number. So in this case, I'm starting out in moles of H2, and I don't want that unit anymore. So I'm going to put that in the bottom. I want to lose it. I want to go to moles of H2O, so I'm going to put that on top of my factor. Now, I understand that in previous problems, I always said put 1 with moles. This is the exception to that rule. When you're going from moles of one thing to moles of another, you cannot assume that you just write 1 to 1 as your numbers. Instead, you have to go back and use your coefficients in the balanced equation. So I'm going to go back up here to this balanced equation at the top of my screen right now, and I'm going to look. H2 has a coefficient of 2, so I'm going to write 2 down there next to it. Then I find water. It has a coefficient of 2 also, so I'm going to put 2 in the top. Now, my units are going to drop out of moles of H2, and I'm going to be left with moles of water, which is what I want. So mathematically, what I'm going to do is I'm going to plug 2.5 into my calculator to start. 2.5 times 2 divided by 2, which should give me an answer of 2.5 moles of H2O. All right, pretty simple since it was a 2/2 ratio. But what about if it's not always a 2:2 or 1:1 ratio? So sample problem number 2, how many moles of water can be produced from 2.5 moles of O2? I'm going to start with 2.5 moles of O2, and it's very important that you don't just write 2.5 moles. You need to be specific about moles of what, so that you don't lose track of where you're at in your conversion. 2.5 moles of O2, and the problem is asking me how many moles of water, so I need to change that to moles of H2O. Again, to go from moles of one thing to moles of another is going to be a one-step conversion factor. I'm going to put moles of O2 on the bottom because I want to get rid of it, and I'm going to put moles of H2O on top. In order to figure out what numbers to put here, I have to go back to my balanced equation, and I look, I've got 1 mole of O2, so I'm going to put a 1 next to the O2, and I have a 2 in front of the water, so I'm going to put a 2 here. So this time in our calculator, we're going to start with 2.5. I'm going to multiply by 2 and divide by 1, and that will give me 5 moles of H2O. Now the critical thing here is, in order to convert from moles of one thing to moles of another, is that you have to have a balanced equation, remember? So now I would like for us, I've got a little typo here, let me fix this, to take a look at the 12-1 practice problems, which is what is assigned as homework tonight. So if we go here, 12-1 practice problems. Some of these equations, like 2, 4, 6, 7, 10, they give you balanced equations already, which will be helpful, but the others don't. Like number 1, it says lead will react with hydrochloric acid to produce lead 2 chloride and hydrogen. How many moles of hydrochloric acid are needed to completely react with 0.36 moles of lead? All right, so we have to start with writing a balanced equation, but I'm trying to kind of help you out because that should maybe sound a bit familiar. If we look back at last night's homework, question number 1 on that homework was, lead will react with hydrochloric acid to produce lead 2 chloride and hydrogen. Exact same thing. So if you did last night's homework and you got it correct, which I have graded all the homework that's been submitted to me and returned it to you now, then you can take a look at that and it should give you your balanced equation. In fact, I think pretty much all of these equations that were on last night's homework are the equations you're going to need for today's assignment. There are a few, like number 4, propane combusts, that actually relates to problem 7 on the homework tonight, and they gave you that balanced equation, but I was trying to kind of help you out here. So let's do number 1 together. So we need to go back and look at our homework from last night and copy down the correctly balanced equation. So I have that Pb plus 2HCl yields Pb Cl2 plus H2 as my balanced equation. All right, so we start with the balanced equation, then we write down the number and unit that they are given. Let me switch colors here. So they say 0.36 moles of lead. So I'm going to write 0.36 moles of Pb, moles of lead. And I am supposed to change that into how many moles of hydrochloric acid. So blank moles of HCl. All right, I can do this in one step to go moles of one thing to moles of another. I'm going to put moles of Pb in the bottom because I want to get rid of moles of lead. I'm going to put moles of HCl on top. I go to my balanced equation and I look at my coefficients. There's no number written in front of the PB, so I assume that that is a 1. I look at HCl, it has a 2 as its coefficient, so I have to put a 2. So on my calculator, I'm going to put 0.36, because that's the number that I'm starting with. I'm going to multiply by 2 and divide by 1, and that should give us an answer of 0.72 moles of HCl. What I don't want to see you do is just write an answer like 0.72 and circle it and not show me at all where you got your work from. You have to show me your balanced equation, have to show me where you started, your conversion factor, and then the number in unit of your answer. Let's try number 2 together. How many moles of HNO3 will be produced when 0.51 moles of N2O5 reacts according to the following equation? We should first begin and make sure that everything is balanced. It looks like it is, but let's just double check. So we've got 2 nitrogens on the left, got a coefficient of 2 here, so 2 times 1 gives me 2 nitrogens. Nitrogens are good. Oxygen, I've got 5 plus 1 more, so that's 6. So then 2 times 3 is 6, so that's good. And then hydrogen, I have 2 on the left, and I have 2 on the right. All right, so that checks out well. Our equation is balanced. Now I'm going to write down the number and unit that they give us in the problem. In this problem, I have 0.51 moles of N2O5, and they are wanting us to convert that to moles of HNO3. They say how many moles of HNO3. All right, so we're gonna set up our conversion factor here. I'm gonna put moles of N2O5 in the bottom. I'm gonna put moles of HNO3 on top. Then I go to my balanced equation. There's no number written in front of the N2O5, so I assume it's a 1. I look at my HNO3, it's got a coefficient of 2, so I'm going to put 2 on the top. So I start by plugging in the number I was given, 0.51. I'm going to multiply by 2 and divide by 1. And I have that should give me 1.02 moles of HNO3. Your homework assignment tonight is to go through and finish 3 through 10 on this front side of the worksheet. Then the back side of the worksheet looks like this. There's 13 through 17. Some of the problems, they give you a balanced equation. Some of them you need to come up with that on your own. I would like to make one change on number 17. Down here at the bottom, says zinc reacts with H2SO4 to yield ZnSO4 and hydrogen gas. How many moles of hydrogen will be produced if 0.36 moles of zinc react with an equal amount of H2SO4? Demonstrate that the law of conservation of matter is obeyed in this reaction. We are going to cross off this demonstrate that the law of conservation of matter is obeyed. You don't have to answer that part. And I'm also going to modify and give you some freedom on this. I want you to choose any 3 of these 5 problems. Any 3 of them must be done for homework. You can decide. My class today asked if they could do the other 2 for bonus, and I agreed that you may do the other 2 for bonus if you wish to do that, but you must at minimum do 3 out of these 5, and then you must do the rest of the 10 problems on the front side of this worksheet and upload your assignment by 8 a.m. tomorrow. If you have any questions on this, please let me know. But remember, stoichiometry has to begin with a balanced equation. If the equation is not balanced, it is not useful.